Good morning, good afternoon, and good evening. We are indeed a global community working to preserve the lifestyles we enjoy and protect our loved ones. I'm Hadass Levin, Vice President at SIGA, and I want to welcome you to SIGA's OT Solutions webinar. Over the next 40 minutes, we'll be addressing how to prepare for a cyber attack and protect your industrial assets. As a matter of agenda, we're going to cover very briefly a quick introduction, reviewing recent cyber attacks against industrial facilities, and why is it so difficult to secure OT systems. We're also going to have a quick overview of current security methods and talk about the missing link, if you will, that is monitoring raw electrical signals from the source, which is an essential solution to any existing IP-based solution or system that you might have. A quick summary and questions and answers. We anticipate that this webinar will require about 40 minutes from start to end. As a matter of housekeeping, please use the Ask a Question box to send us questions throughout the webinar. We'll try to address as many questions as possible during the question and answer session at the end. If you'd like to request a copy of the slide deck or additional information, please feel free to email us at info@sigasec.com. We recommend watching this webinar in full screen. I'm very pleased to introduce our insightful presenters today. Ilan Gendelman, an experienced IT professional with over 14 years of managerial experience, holding a Master's of Science degree in Computer Science from the Weizmann Institute, who serves as CTO at SIGA OT Solutions, and Daniel Ehrenreich, with over 25 years of experience, certified ISO 27001 lead editor and international lecturer in the field of industrial control systems and cybersecurity. So without further ado, I'll let Daniel take us forward for the first section of our webinar. Thank you, Daniel.
Thank you very much, Ilan, Hadass, and I would like to start with a little bit of introduction. We all know that the cybersecurity for industrial control system primarily started less than a decade. And what happened that it was a major surprise to ICS experts, because this was the first time they realized that air-gapped ICS are not safe. Following that, we started to see new vulnerabilities being detected in industrial control systems, and the attackers took advantage of negligent and legacy-type ICS architectures and started to develop new attack vectors in order to generate outage, in order to cause damage to machinery, and in worst case, we might even see hurting people. In parallel to that, we saw another trend that management demanded to receive information from the ICS in order to enhance the productivity, in order to improve the process of supplying raw material and more, in order to allow that connection between the IC and the ICS and the IT, where we have seen traditionally air-gapped, new technologies like firewalls, demilitarized zone systems, and even unidirectional data diodes were introduced in order to allow the cyber-safe passing of the information from the ICS to the IT and access by the management, by purchasing people, by logistic people, and more. But we always ask ourselves, with all these technologies, did we eliminate the cyber risk? Are we safe? And the answer is definitely not. And in the couple of few slides, you will see how it can be done better. Cyber attack to industrial control systems, we are talking about three major attack vectors. We are talking Actually, these vectors are group of vectors because under each section we can see many different possibilities. We talk about internally generated cyber attacks. When somebody is entering to your facility, he can access your PLC or your one of the computers, and of course he can enter the USB stick or a service computer which is affected before, and suddenly your system is under attack, and practically anything can happen from that moment, depend on the attack vector. The second one, well known, is the externally generated attack, usually through the internet, and always, or in most cases, it starts with social engineering actions, where attackers are managing to penetrate to the IT network by sending emails with all kinds of links. But anyway, because people are not aware of the risk, they may fall to the trap and they allow the attacker to enter to the IT system. Once the attacker is entering the IT system, he will start compromising the firewall or the DMZ step by step. Of course, it's not an easy operation, but it can be done by experts. But last one, which we didn't pay enough attention during the past years, is the supply chain related attack. Where are we buying the PLC? From which supplier? From which supplier are we buying the computers and the software? Are these suppliers the original manufacturer representatives, or they are some type of dealers? And in some cases, we are not aware of that the malware may be already included in that piece of hardware or in the software, or even when we are downloading an upgrade to an antivirus or upgrade to an operating system from a not formal source, the malware will penetrate. So due to these three reasons, we are highly concerned, because we know that if the attacker is truly determined, he will be able to penetrate our ICS and, of course, cause the damage. Speaking about ICS OT security, why it is so difficult? Why we cannot deploy similar solutions like we did for years for the IT system? For a couple of good reasons. Because these systems are continuously operating 24/7. They cannot be shut down, and also the operators are not are always telling us, if it's working, don't touch it, don't fix it, it's working fine, why you are worried? And this is a major stumbling block and not allowing us to do the needed upgrade. Furthermore, the systems, we all know the systems utilize legacy type products, legacy type software. When we speak about IT systems, 3 years, 4 years, this is mostly what we are using, a computer or an operating system, and then we are upgrading. When we speak about the ICS, you can easily see 10, 20, and don't be surprised, 30 years systems installed, working perfectly without any problem. Another difficulty that we are facing is that the organization do not have accurate information about what is installed, about which device is communicating with which device, which is the exact software version or the PLC version. They don't have this information because many years ago the documentation was not done properly. But we know that every change, whether it's a PLC replacement, whether it's a operating system replacement, every change may cause a safety risk. And this is the reason why we always refrain from making changes or making upgrades, improving the system. But because we know that the risk is there, we must think out of the box. New solutions must be brought to the ICS cybersecurity industry in order to enhance and the resiliency to attack. It must be simple to deploy, of course. It should not require any changes. It should be an add-on type deployment without changing hardware, without changing software. And of course, it should not increase the cyber attack surface. This is very important. Sorry. Let's look at the wide range of cyber defense solutions which we are already deploying to our system. We talk about physical security and perimeter surveillance. We talk about hardening of the computer, hardening of the controller. We deploy strong authentication wherever it's possible, and of course, for those devices which are supporting authentication, we deploy encryption where it's possible. Primarily, I speak about wireless type network to distant devices. We deploy intrusion detection systems for network data analysis and visibility analysis. Of course, no need to mention firewalls, DMZs we are doing. Segregation of the network between the IP and the ICS using unidirectional diodes. We are doing that as well. We deploy whitelisting in our computer. We do periodic assessment to detect unknown links and some backdoors. And we also take actions to comply with regulation. But can we assure business continuity? Can we assure that the attacker, for the attacker, it will not be easy to attack our system? We don't know. We know that everything is possible. So let's see what can be done. When we are looking at the famous Purdue model, the Purdue model is the one that is showing the organization architecture. It's going from level 0 to level 5, and in the level 1 we see the PLCs, those devices which are controlling the machinery, the turbine, the pumps, the boilers, the PLCs. About layer 1, about the layer 1 we have layer 2, where we have the automation servers, the HMI, the engineering station. All these are computers which are helping us to manage the operation. And we are, of course, monitoring and defending the communication between layer 1 and layer 2. So we are paying attention. We are paying attention to all areas where risk is that someone will penetrate to our system. So we are already doing it fine. But is this enough? And as you can see, it is not enough, because we did until now, during recent years, we didn't pay attention to the layer 0. In the level 0 of the Purdue model, we have the sensors, the actuators, the relays which are activating the pump. We even have some smart devices. And in the modern systems, we can even find intelligent electronic devices like protection relays, computerized power meters, and these are all at level 0 of the Purdue model. In many cases, we see that these devices do not receive strong physical security. Sometimes they are installed out of the building. They are not well protected, and if something happens to these devices, then everything will go wrong. We all know that the entire operation of the ICS is depending on the sensors, the values which these sensors are measuring. So if something will go wrong with these parameters, the entire industrial control system will not work properly, and we can no longer rely on what we see on the HMI screen, no matter which HMI software, no matter which PLCs we are using. We cannot trust what we see on the screen. So the conclusion is that we must take immediate action, and specifically for systems which are controlling critical infrastructure and high-risk operations like chemical plants, like boilers and gas turbines. All these installations have many sensors at level 0 of the Purdue model. Some of them are very critical and must be monitored. Some other may be not so critical, and they may cause a quiet shutdown. But there are definitely sensors. When if something will go wrong, the ICS will go out of normal operation. Let's look in a real case. In this real case, we see in the upper side of this picture the SCADA system. In the lower side, we see a water pump station, and we see the PLCs connected to this pump station. So let's talk about few scenarios. The sensor may fail to operate. It may be out of range. Why? It may be a malfunction, or maybe it was mechanically damaged, or it was manipulated. Anything can happen to that sensor which is attached to the pump. So what can we do to improve the situation? Upfront, we could install a second sensor. We could upfront install a second PLC, which will monitor both sensors, or two PLCs which are monitoring two sensors. Almost anything is possible. But we need a better solution, a stronger solution. We can deploy an anomaly behavior analysis on these electrical signals, and they analyze exactly what happened. And the beauty of this solution is that the outcome of this analysis is not dependent on the legacy type SCADA ICS, but we are directly looking at the level 0, at the field level of the operation. So by adding dedicated monitoring to level 0, to the sensor, and by deploying out-of-band communication, a different communication network, then we significantly improve the operating safety and reliability. With this slide, I completed my introduction, and I'm inviting Ilan to continue presenting this slide.
Thank you, Dan, for this thorough review. I would like to continue and add some more aspects to the question of why, after decades of experience in protecting IT networks and versus cyber attacks, why is it not straightforward to import these solutions to the OT world, and why is it still so challenging to protect the OT environment? The main thing I would like to start with is the fact that IT is conceptually different than OT. And the main difference is, what are we aiming to protect? So while in the IT world, the real thing we're protecting, the assets of the system, is the data. All various aspects of data, and the classical triangle is confidentiality, integrity, and availability, and pretty much everybody dealing with IT, that's what stands before them. But if we look on the OT world, it's completely different aspects and completely different values. So the main thing which is important in the OT world is operability. And derived from that, what's important to the operator is observability and controllability. And if you take that and you look on even the terminology used for the asset, the real asset of OT world is no data, is the actual process, is the real world manifestation, and the process and its outcome. And even the usage of terminology, when you use assets in the IT world, what basically mean is network entity, is something, basically a server relying on the network, manipulating one way or another data. And even today, when you buy a product which refers to the OT in terms of asset management, what it actually manages is entities on the OT network. But these are not the actual assets. This is not what we aim to protect. We aim to protect the process, the real world. The second thing I would like to refer to is the uniqueness of the OT architecture. And this is a simplified version of the true diagram that Dan showed. And the important part where I want to stress is the uniqueness and importance of level 1 layer, the PLC's layer. And this layer, and if we look on a more simplified, a more abstract diagram, this layer is basically separating everything above it, which still talks in kind of IT language of the OT world, which means protocols and bits and bytes, and between everything that happens below level 1, which speaks in the language of inputs and actuators, and mostly speak in the language of currents and voltages. And the actual assets of the OT world rely below the PLC. Everything above it is intended to allow the operator the observability and controllability. The last and important aspect that I want to discuss is who is the attacker and what does the attacker wish to gain. So as we all well know, the OT world is facing a very broad range and very diverse range of potential attackers. If you look on one end, you see just people downloading SCADA exploit packs from the web and just non-specific targeting, trying whatever is available, whatever is accessible, using Showdown or whatever it means. And on the other hand, you see the most sophisticated attacks, government level, highly funded, very sophisticated with lots of funding and investment of time and money. But the main range which poses the most valid danger to the OT world is the sophisticated attackers which aim mostly to monetize the attack. And if we look on this mass area and we ask what would the attacker try to gain, or what will be the result or the outcome of the attack, and this was very nicely described in DEFCON 23 with a very, very convincing example in 2015, the first thing that comes in mind is equipment damage. And that's probably the first thing that people stress about, and you think of overstressing equipment and the violation of safety limits. If you think in terms of value and monetizing, first of all, in most cases, it's irreversible. And irreversible is not necessarily the best outcome for monetizing their attack. The collateral damage is, in many cases, unclear. It might result with the loss of life or different damage than what was expected, and might transform to something which is referring to compliance, and must be reported to government authorities. On the other hand, a compliance violation, meaning an attacker can cause safety, occupational environment, or causing pollution, a contractual agreement, everything that needs to be reported. The benefit of this, but this is not necessarily always a plus, that it has to be reported. It has to be reported, and it's hard for the asset owner to keep it silent. Again, the collateral damage is in many cases unclear, and the clear downside of reporting to authorities, this is very likely to lead to an investigation by government authorities, which is not the best benefit of an attacker. So the main thing that if you look at it from the perspective of money, that relies in terms of attack is the production damage, meaning attacking the product quality, the product rate, the operating cost, the maintenance cost, the maintenance effort. And the key aspect of this type of attack is that it's a very prolonged attack, and this is probably the best outcome for somebody trying to monetize its attack. And if we look on the existing approaches in protecting the OT world, and this is here you can see a very small example. It's changing very fast, growing very fast, and lots of important and valid solutions, but most of them imply the ideas coming from the IT world. And they aim mostly to build high walls. The building of high walls is crucial, it's important. It's protecting the OT domain. It's trying to identify dangerous or potential dangerous communications over the network. But if you take, and also the solutions have their own limitations because they look at protocols, they in most cases need to deep inspect a large variety of protocols, mostly in many cases legacy protocols. They tend to install agents. Altogether result with lengthy implementation, high false positive rates, and a lot of difficulties in applying a solution. But if you take all said before and combine it with the understanding, which there are white papers on the subject for a long time, for 2015 on, definitely, that no matter how high will be the wall and what we will place around the OT arena, eventually, a persistent attacker will reach the PLC level 1, and the PLCs will be compromised because one faces the intimate sophisticated adversaries, and because of the demands of the OT, which support manufacturing attack, the natural 0 days vulnerabilities, and we all are familiar with the famous examples of what happens when in a high ISO environment faces extremely determined adversaries. Combining all together the result of the unique architecture and the fact that the PLC layer will be breached, once an attacker reaches the level 1, it allows him to completely isolate the real assets of the OT world, which is the process, versus everything that's being seen above, which means everything seen by the operational tools, by the monitoring tools, by the cyber tools, by the operator itself. And this can be held with no time limit and allows a full separation between what's happening and what's being visible to the outer world. And the main aspect here is the infinite dwell time. So if we look on that and we try to define what is the requirements of future OT cyber solution. First of all, it needs to be designed for the OT, meaning take in account the unique architecture, take in account what is the actual asset of the OT world. It has to be practical to be installed in the OT environment with all the limitations, mainly operational, safety. It has to be compatible with new and legacy system, and legacy system is completely different thing than IT. You will be seeing legacy systems for the coming decades still. And it cannot challenge in any way, not the safety, nor the operational requirements, but also it cannot add any additional risk aspects in cyber terms to the monitor system. At this point, I want to describe the solution that Siga is focusing on based on everything described before. And this is directly monitoring growth signals coming between the PLC and the asset itself, which means the sensors and the actuators, and using this raw information to alert how a process looks like, what a valid process is, and alert when any deviation is marked on the process. So this is how typical installation looks like. We install an isolators, which is an off-the-shelf, well-known product which is highly familiar, only by everybody from the operational world is highly familiar with. The role of the isolators is to 100% make sure the signal itself, both either it's a sensor or an actuator, is intact, while duplicating the signal and completely isolating the two systems, the actual OT world, the production world, and the monitoring system, not allowing any dynamics, not by accident, not by attacker, from one system to the other, not even allowing an attacker in the OT network to identify it's being monitored by the SIGA platform. Using this information, this raw signal, which is highly sampled and is 100% untempered. This is for sure representing what the process looks like. We transform it to the analytical engine and using both user knowledge and machine learning tools and algorithms to learn how a valid process looks like, to define a perimeter around the process and alert on any deviation from it. Alert using to other sources, to SIEM, to email, to SMS, direct user information, and also to the SIGA dashboard. So what the SIGA dashboard is offering is 100% untempered observability. It's both in real time and historically. But once an alert is being identified, it sends information and alerts what exactly, which part of the process is showing anomaly, why, in what aspect is it deviating, showing all the relevant information for the people on site to react. Just to end it, few quickly case studies just to explain more deeply how the system is installed and how does it look in real life. One of the beauties of the systems is when you look on a cyber solution installed on live OT environment, it's almost impossible to really live test it because the only real testing is a pen testing on the actual live platform, which rarely can be allowed, and even when allowed with huge limitations. When we look on this system, while it's installed as cyber solution, it's monitoring any deviation of the process, which both relate to cyber and to operation. Hence, it's being tested daily, every minute, whether it's identifying or not identifying any process operational deviation. And besides being tested every moment, it's also bring immediate value to the client in aspects of process operational deviation in addition to the cyber aspect. The first example is an example of a water utility of a major water reservoir in Jerusalem, and it compares what is being monitored by traditional SCADA solution, which is the orange, and the system, which is high sampling the raw data. And one can see that even in a slow-paced environment as water facility, the gaps between what is seeing and what is reporting, between what's actually measured by the monitoring system of the raw signals, is huge, and sometimes the gaps are just enormous. So besides being 100% untempered, this information is also in many cases unavailable to existing SCADA tools. The second example is a lab installation prior to installing in a water facility, in live water facility in Singapore. And the aim of the lab installation was a full and real installation was to allow the real testing of cyber attacks. 3 scenarios were in place, manipulating the process, the water process. All 3 were fully identified. The third one is an example from a chemical production plant. And what I want to exactly referring to what I said of being tested in the operational world while being a cyber solution, if one will look on the main on the graph above, the main thing I would like to show is how complex and how diverse the process is. And no matter how diverse it was, the system did not alert on the changes in the process, but did alert when there was anomaly, when a real anomaly in the Bermuda operation. And the last case study is an example of installation in electrical production. This is a GE Mark V gas turbine with thousands of IOs, and we were installed on a small, carefully selected subset of 70 IOs, learning for a period of time how the proper gas operation of the turbine looks like, and later on we were tested by the operators, changing parameters of the operation on the live turbine, and all changes were detected by the system. Concluding with that, that's back to you for Q&A.
Thank you, Dan, and thank you, Ilan. Very enlightening. I'd like to try and address some of the questions that we received so far. So we received the question. I'm going to just read them verbatim, and please, again, remember, you're more than welcome and encouraged to submit whatever questions you might have. We'll do the best we can within the time that we have. One participant wrote, "Hello, PLCs are on the production floor. How outside of the plant people can compromise data inside the plant? There are no RF goes outside of the plant." And Dan, perhaps I'll let you take that over and address that question, please.
Thank you, Adas. It's really, I'm glad to receive this question, because this question is coming to my, I believe, second slide, where I was talking about internally generated attack, externally generated attack, and the supply chain attack. Of course, the best would be if no one could enter to our facility. But we should remember that on the shop floor, we see external service people, some disgruntled employees who, for whatever reason, would like to cause a damage. So we must take into our consideration that people who are interested to cause a damage can enter to our production floor. So we always say, in order to protect yourself, you must believe that somebody can enter to your facility, and then you will have to prepare yourself. So the solution should be such that you will identify that attack as soon as possible.
Thanks, Dan. We have a second question here from the audience. Must the SIGA site dashboard have its own workstation, or can it be used with other applications on a user's computer in the control room? Ilan, can you take this one on?
Definitely. So it's a straightforward and easy answer. They definitely can be used in using computers. It's a web dashboard, which means that it can be ran on any chosen computer, and definitely doesn't have its dedicated workstation. Moreover, clearly can be used on more than one computer at the same time, both in control room or engineering room or any other place.
Great. We have another question here, very interesting. Ilan, I'm going to direct this to you as well. So for the use cases demonstrated, were in-band security solutions incorporated in the OT environment? Question. Per my understanding, the only way to effectively use SIGA is to also have a complementary network security type in-band solution. Thank you, Mr. Farouz. Go ahead, Ilan.
So this is a very correct understanding. When I was referring to building high walls, it was in terms that the high walls are important. They are crucial. I mean, it doesn't make sense not to put them. What we are aiming to in this aspect is that building high walls is very much insufficient. When you look in terms of what the assets are, it's just not enough. But yes, we are installed as part of an environment where a network solution are in place, and it's important they are in place.
Thank you, Ilan. Another question. To summarize your solution, this product is pushing cybersecurity down to the instrument level. Is this an accurate statement? Maybe Dan, can you take us forward on that?
Thank you, Adas. When I presented my introduction, we have seen the Purdue model where we have the level 0, level 1, and level 2. Traditionally, until now, we focused on level 1 and level 2. And we didn't pay enough attention to level 0. So what we see from this presentation, and what we always knew before, it's nothing new, that the damage to the boiler, the damage to the turbine, or the damage to open a valve in a chemical plant is always done by the PLC in the bottom floor and the actuator, or by the sensor. So I wouldn't use the word pushing down the security, because you still need to have the cyber defense for layer 1 and layer 2, but in addition to that, it will be an excellent and justifiable investment to protect also the sensors by monitoring electrical parameters, analyze it with much stronger computers, which your legacy system is using now, and make a correct decision about what is happening.
Thanks, Dan. We have about another 3 minutes here. Another question that came in: how do you tap into the sensor wiring to send signal to anomaly detection engine? And what does the anomaly engine look like? Perhaps, Ilan, you can address this?
Definitely. So it's actually two separate questions. Regarding the first one, that's exactly the installed part, which is the isolator. The isolator, which there are many manufacturers manufacture this operational device, is taking the signal and, without affecting it in no way, duplicating it to allow to be monitored on a parallel system. In many cases, we are installing the type of isolator we recommend, but many clients install their own isolators, and this is part done by the clients because they know that once this is installed and we are working on the other side of the asset, there is nothing that can affect the system itself. And once the signal is duplicated, it's being changed from analog to digital, and any sampling rate we choose, and passed to the analytical engine. The analytical engine itself is a multi-layered platform that we built. Basically, that's what we do. That the focus is SIGA, not the actual physical installation, but the algorithms in the core of identifying how the process looks like. And this multi-layer takes into account the combination of information extracted from the user and the machine learning algorithms that we developed in order to identify how a process looks like.
Great, thanks, Ilan. I'll try and speak quickly because there's so many questions. A follow-up question. There's a detection, this is a detection-only platform, right? Meaning once the malicious command has been executed, there's no way to stop it. Dan, maybe you can just answer that very quickly. There's a lot of questions. We'll try and do as many as we can.
Well, thank you for asking this question. As a matter of fact, I should start my presentation with this topic exactly. The difference between the IT and the industrial control system is that in the IT we can do an intervention. We can stop a process. We can unplug the network cable. The best practice for industrial control system is always not only for a specific issue at the sensor level, but for layer 1 and layer 2. The best practice does not allow to interfere with the system because there is a risk that by interfering with the system, you may cause a bigger damage than the cyber attack would cause. So I must clearly say that yes, by having a fast and accurate detection of where the problem started, we will be able to take an instant action of how to stop the attack without causing a damage or a worse situation.
Okay, we have at least a dozen more questions, but we're going to have to cut this off. This is our last question we'll be able to entertain, but please feel free to follow up with us directly. The question is, there is it necessary to wait a plant detention to install the equipment to receive the input-output data of the sensors and actuators? Or can you do that with the system in production? And maybe Ilan, you'll take that one on.
So the easy answer is yes, it can be done while this is in production. It's basically the client's call. It's very straightforward to do it while it's in production without affecting the production. In some cases, we installed them when the system was downtime, but this was the client's call. And in many cases, we installed while the system was fully in production.
I'm very sorry, but we're going to have to really wrap up here. And again, I apologize that we weren't able to address everyone's questions. There's just too many to really deal with. Again, I encourage you to reach out to us. Please feel free to visit our website. We are a 2018 Gartner Cool vendor. We have been awarded the Seal of Excellence from the European Community Horizon 2020. We're a U.S. patented technology and IS 27001 certified. So please do reach out to us. We'd be more than happy to address any concerns that you have and to be in touch and to also make a demonstration of our technology to you. And again, I encourage you to reach out to us. Thank you so much for joining us, and thank you again, Dan, and thank you, Ilan, for just an absolutely wonderful presentation. Have a great and safe day, everyone.